Hi guys, this is me, Premika, p.372, and today I'm going to be showing you question 62 on page 372. So the first question asks us to determine whether which of the following points over here satisfy the statement below. So let's first start off with question A. Question A asks us which point is at f dip equal to 0. But before we go into that, let's look at what is exactly is f dip. Well, f dip, as we have learned, is basically the slope of the following graph, right? So the question really asks us to determine which point that equal to the slope will have 0 value. And the answer is at the point x0 and x4. And here's the following graph. See, at point x0 and x4. And now let's move on to the next question. So for question B asks us whether which point have the double dip. We call this a double dip equal to 0. So f double dip. When we see this double, it doesn't mean slope anymore. What it means is that it is the rate of change of the slope. So when the rate of change of the slope equal to 0, that means that the slope that means that it is constant, right? When the change equal to 0, that means it's constant. And so the point that is constant is at x2 and at the point x3, as we can see from this following graph, x2 and x3. And now let's move on to question C. Question C asks us which point is at dip x where dip x doesn't exist. So where dip x doesn't exist, which means that the limit isn't the same, right? From the limit on the left and on the right isn't the same. So it can either be on the left is negative and on the right is positive, or it simply has the different value. So this happens when there is a vertical tangent or sharp turn. And the answer for question C is at point x1 over here, x1. See, there's a sharp turn. And now for C, f has a relative maximum, right? And this goes the same way with questions and so we can observe from the graph that the point at the relative maximum is x equal to 1, right? The sharp turn over here, yeah. And now, last but not least, question E. By using the same method as D, we could find point x2 and x3 at the point of inflection. And that's it for today. Thank you for watching.